Okay, our next speaker is Kyle Mozley. Kyle is a meteorologist from the National Weather Service in Pueblo, Colorado. He attended the University of Oklahoma, getting a BS in meteorology, became interested in teleconnections and their relation to climate predictability. When he arrived in Colorado, he started looking at the ENSO, La Nina, El Nino patterns, and producing some climate forecasts, which I receive monthly, and I'm always really happy to get. I'm really excited about this talk because we've had a weather outlook talk for many years using different groups in the Weather Service. It's been a while since we've had someone from the Pueblo office, which is really exciting to see. And so please welcome Kyle.
All righty. Let's see here. Am I going the wrong way? Big green one. There we go. All right. So I came about this study based on teleconnections, and a lot of it was because of when I arrived in Colorado, it was always El Nino is always great, La Nina's bad. So was that true or not? So I started looking at it, and then I got to thinking, maybe there's other patterns out there that also influence our mountain precipitation. So my goal was to determine the large-scale weather patterns, or teleconnections, what kind of combinations can lead to above or below normal precipitation across Colorado's mountains. So what is a teleconnection? It's a significant link between weather patterns that occur in different parts of the world, usually over thousands of miles. They're often used to describe climate variability on monthly or seasonal timescales. The major teleconnections that I've looked at are the Pacific North America, Arctic Oscillation, North Atlantic Oscillation, the Pacific Decadal Oscillation, the Madden-Julian Oscillation, and the El Nino Southern Oscillation. Most of these are on smaller timescales, 2 to 3 weeks of predictability. Some of them are on decadal timescales, such as the Pacific Decadal. So those happen over a 20 to 30 year period. Madden-Julian Oscillation is several weeks. And then El Nino, the Southern Oscillation there, everybody's probably more familiar with that, can occur on a several year basis. So we'll jump right into a few of these teleconnections. So the PNA, Pacific North American, it's a shift in the upper level pattern along the west coast. You can see during the phases, during the positive phase, the upper high is right along the west coast, whereas we get into the negative phase, the high shifts off the west coast, and that impacts the storm track for Colorado. So when it shifts into the negative phase, the storm track's a little bit further west. We get these deep lows that come in and can produce periods of wet weather across the mountains. Basically, the predictability beyond about 2 to 3 weeks is fairly poor, but we can use this in our analysis of what's going to happen over the coming days. Mostly impacts our precipitation, not so much temperatures across Colorado. And the graphs over here, those are some of the predictability tools that I use to help forecast the PNA. And most of the teleconnections that we'll look at is fairly similar. I use the same kind of tools. The Arctic Oscillation, it's more of a temperature impact. It's when we get into a negative Arctic Oscillation, or AO, it allows cold air to come down the central U.S. into the Colorado Plains and can reach into the Front Range as well. Again, predictability beyond about 2 to 3 weeks is fairly low. It's more common during the winter, and it's probably not as influential for our mountain precipitation as some of the other teleconnections, but it does play a small role. The North Atlantic Oscillation, it's determined of the strength of the Greenland high, You're thinking, man, that's way out there? But yes, that can influence our weather here. The positive phase opens up the Gulf of Mexico to moisture, so it's transported up into Colorado. And if you get that moisture that comes up and you get that P&A pattern where the storm tracks west, you get all that convergence right across Colorado, and it could be responsible for periods of precipitation and, again, colder air across Colorado. The predictability is a little better, about 3 weeks to 4 weeks with that. Now, the Pacific Decadal Oscillation is about a 20 to 30-year period. It's fairly stable. Currently, we're in a very negative phase of it, so we're not moving out of that negative phase anytime soon. It switched probably around 2005-ish. Before that, it was in a positive phase back through the 80s and 90s. It has very distinct wet and dry patterns across Colorado. The positive phase is typically when we see wetter conditions across most of the state. Being that we're in a current negative phase, probably more on the drier side as we go through the winter. That can be one of the things that might be driving our weather this winter. An important note is the data that I used. I used our co-op observer program and the SNOTEL data across Colorado. Part of the problem with some of the SNOTEL data is the period of record may not be long enough to pick up on the Pacific Decadal Oscillation. So I have to rely a little more on our observing program, which goes back much further. But I have been able to use the SNOTEL data, especially the sites with the longer records. The Madden-Julian Oscillation, this is one of my favorite ones that I use. Again, it's a 40 to 60 day cycle. Typically travels from west to east around the globe. And I use what we call a phase space diagram, which is this right here. And basically, it gives us what has happened with the MJO as it travels around the globe, what the forecast is for the next 2 to 3 weeks, plus an ensemble spread with it. So it kind of gives you a little bit more confidence of what the MJO is doing. The further out you go from the center is determining the strength of the MJO. So in this case here, you can see it's got a wide berth around the center, so our MJO event is quite strong. This was from March of this last year, and we had some active precipitation events with this Madden-Julian Oscillation. Another way we can look at it is look at our 200 millibar velocity potential. When Andrew talked earlier, he talked about the 500 millibar level. So same type thing, we look at 200 millibars, which is a little further up. And when we look at this here, the brown areas are areas where you have sinking motion, where you can't get thunderstorm activity convection. And the green areas are areas where you have upward motion. In that area, you have difluence aloft, you can get storms develop, and that's where you get the thunderstorms. And that's another way we can track it around the globe. When we have what is called a one-wave pattern, where you have this kind of dipole, where you've got the browns and the greens, that's a very active MJO period. Now, if we had multiple areas of brown and green, that's what we call a wave 2 or a wave 3 or whatever, however many you have. And that means you have more influence from other types of weather cycles that are going on out there. We have Kelvin waves, Rossby waves, but those can interact with the MJO. Another thing the MJO is responsible for are atmospheric rivers. We've had some talk about that a little bit today as well. So typically when we see the MJO move off the Indian Ocean and into the maritime continent, Thailand, kind of in the Philippines and into the Western Pacific, we can get what we call an extension of the East Asian jet. So you're tapping deep tropical moisture, and that moisture rides right up into the Western US. So the MJO is a very important oscillation that we can monitor and track. One of the things that has been worked with has been composites for precipitation. And based on the MJO phase, whether they're wet and dry, which is the green and the brown here. And then we have a skill score, so significance. So right here we see by phase, what we want to see is the purple. So if we have purple areas, let's see here. So, whoops, wrong way. When we look at, say, phase 1, we see these purple areas here on the eastern U.S. We see it's got real high correlation to wet precipitation. So that can be another clue that we're having, we can expect maybe some precipitation. So if I take the phase diagram and I can track where the NJO is going and say, well, it's going from phase 6, 7, and 8 over the next 3 weeks, I can come here and look at this and say, well, during the phase 6, 7, and 8, we have increased potential for precipitation or dry conditions. So it's a great forecast tool. The one that everybody is probably most familiar with, and that started this study that I did, is El Nino Southern Oscillation. Basically, it reoccurs, the cycle reoccurs every 3 to 5 years. We go from a negative to a positive phase and so forth. It doesn't have to be a full cycle. You can have 3 years of La Nina. We just came out of a three-peat La Nina. We went into an El Nino this year, and we're already going back to La Nina. So, it can be quicker than 3 to 5 years and can last longer than the 3 to 5 years. Basically, you're looking at temperatures across the Pacific, whether they're above normal or below normal. That's how that's determined. And basically, when you get La Nina, it impacts the Walker circulation in across the Pacific and where you get thunderstorm activity, and that's another way that we can track it. So it's not just the ocean temperatures we're looking at, we're also looking at the atmospheric response. What we're looking for this winter is, this is one of the latest forecasts. We can see kind of where the median is here, this darker line. It's showing kind of a weaker event, probably around a minus 0.8 degrees Celsius anomaly. So it's not super strong, but it will likely have some influence this winter as we go through time. On the maps here, the La Nina right here is kind of a big picture of what we can expect. Across Colorado, especially the further south you go, drier conditions, a little colder up north, and then wet across the Pacific Northwest into Northern California. So we'll get into my study now. I used co-op data, and I used SNOWTEL data. My period of record for co-op sites was 1950 to 2016. I figured that would give me a long enough record to get the Pacific Decadal Oscillation in there. And the SNOWTEL sites, I looked for periods of record of around 1980, 1979 to 2016. I used the monthly liquid precip accumulation instead of the snowfall amounts, because snowfall amounts with each storm is pretty variable. And the precip accumulation, I thought that would be a better measure of what actually fell. So for my precipitation, for my above normal, I used whatever the normal value was for that month and multiplied it by 1.25 to come up with the higher end. And the below normal was that normal temperature or normal precipitation times 0.75 to get the lower end. So that bound between 7.75 and 1.25 was the normal range. So I took that and I entered it into a database and compared it to what the different teleconnections were for that particular month. So in this case, we had La Nina going on. We had a positive NAO, a positive AO, and then neutral conditions for the PDO and the PNA. And for this month, we had normal precipitation. It was within those bounds of the 0.75 and 1.25. So if we move down to the next line, here's a below normal month, and I compare it. So La Nina, neutral conditions, and then a negative phase of the AO, and then positive phases of the PDO and PNA. My next step was to compile all these different phases for each month for dry and wet conditions, and then come up with a combination of what teleconnections produced these wet and dry conditions. So in this case, this is for the dry combinations. So for January, I looked at it, and PDO and PNA had very high correlations for dry conditions in January. The percentages there, they are how many sites out of the 53 co-op and SNOTEL sites that I have completed had that particular combination. So for 83% of the 53 sites had a positive PDO, and 96% of the sites had a positive PNA. So for January, if we have a positive PDO and a positive PNA, there's probably a high likelihood that we're going to see dry conditions for January. One of the things that I noticed when I did this is my INSO signal for dry conditions. Do you see it there? No, it's not there. The other ones that look to play a role, the NAO, the North Atlantic, and the PDO, and definitely the PNA. So having that information, I'm able to look at what those forecasts are for the NAO, the PDO, and the PNA. Well, we know PDO is going to be negative for the next who knows how long. But I can use the PNA and the NAO to say, if we have, say in February, a positive NAO and a positive PNA, that gives me it allows me to say, hey, we probably have a better chance of seeing drier conditions. Now, when we flip over to wet, we see INSO does have some influence. And it's not the influence that I was expecting. As we can see, once we get into December, January, and February, La Nina has a little more of an influence. So thinking of this coming winter, we're expecting to be in La Nina, and it's supposed to peak around January. So that could give us some increased confidence that maybe we'll see some wetter conditions. But the other things that we have to look at, say for January and February, and as we go through this winter, are what the other patterns are showing. So if we can get these combinations, so for January, we have La Nina, we have a positive NAO, a negative AO, we can say, hey, we got higher confidence that we're going to see wetter conditions. So I take all this information and I come up with a monthly forecast. I look out for the next 3 to 4 weeks or so, and I use the teleconnections that I use the forecast that I have to say, all right, it looks like we're going to be following this, it's going to trend this way, and that kind of teleconnection tends to lead to a drier or a wetter condition. So, for example, a dry January combination is a positive PDO, positive PNA. If they're forecast to both be positive, I have a higher confidence that things are going to be dry. I look at the MJO forecast. The MJO forecast, the composite skill scores for precipitation. Not presented here, but there's an outgoing long-wave radiation model that's fairly new and has shown some skill for predicting the phases of the MJO. So that can give me an outlook, 1 to 3 months as we go forward in time. So I developed these monthly forecasts, target potential periods of activity, and I email it to our partners. And of course, every study needs some verification, so that's one of the things that I've started over the past few months. I look at the monthly precip accumulation for the co-op and the SNOTEL sites, and I compare it to the normal below and above precipitation, and I compare it to the forecast that I sent out. So for February, I believe this is February, we look at our SNOTEL sites here, and we're all pretty much above normal or at normal. And the forecast for February was wet through around the 10th to 12th, then drying out for the last half of the month. The positive NAO and the positive PNA are helping to drive the current wet signal, but as we lose the positive NAO later this month, we should dry out a bit. And if we look back at the February time frame, it kind of followed that pattern. We had a wet first part of the month, and as we transitioned to the last half of the month, things dried out some. It should be noted that during the summer, it's less reliable. This summer, my verification scores were kind of all over the place. And I think that just has to do with the way the mountain precipitation is, with the variability, and the less influence from these teleconnections. During the winter, however, they've been pretty good. So an outlook for this winter, again, we're heading into weak La Nina conditions. I think we'll still be between that negative 0.5 and -1 range, probably peaking around -0.8. And it looks to peak in the January or so time frame. MJO looks active right now. So we have the storm that's coming through right now. When I put out this forecast a few weeks ago, I was taking that into account, and I said sometime around October 20th, and we're seeing that pattern switch. I looked at it just yesterday for the MJO, and it looks like we're going to see another active period probably around November 18th to 20th or so. So we'll have to see how it progresses, but that's definitely a possibility. All our other teleconnections, the PNA, AO, NAO, given the lower predictability out beyond a few weeks, we're really going to have to pay attention to that as we go forward through time. The PDL, as I mentioned, it's negative, and it's likely going to stay there for the next several years. My final thoughts, La Nina may have a helping factor for wetter conditions as we go through January, February, maybe even late December. PDL will help favor drier conditions in November. NAO, AO, and PNA, like I said, we'll need to watch those as we go forward through time and evaluate them since they have a lower predictability out beyond a couple of weeks. And with that, I'll take any questions.
Thanks, Kyle.
Yeah.
That's great. Yeah, we have time for a couple of questions. Anybody want to know about the future? Yeah, in the back there. Perfect. Thank you.
So you meant. Hello. Oh, there. So you mentioned that like CDOT and whatnot get those emails. Is there a way for patrols and other operations to get those emails with the long-term forecast?
Yeah, I can definitely look into doing that. Right now, I've got mostly like CDOT, the Avalanche Center, some of our media partners and things like that, but I can definitely add people who are interested in it.
Maybe just take a picture of Kyle's email there on the screen and write him.
Yeah, send me an email.
Any other questions?
I was just wondering, what's your accuracy? Do you bat about a 73%?
You know, I haven't done any accuracy type skill scores with it. My verification has mostly been looking at the hindsight for the previous month, seeing whether things were above or below normal, and looking at my forecast to say my forecast that I issued, several weeks ago was, I said above the normal. Did I have any target dates that I could include in there? And I'll have to. That's one of the areas that I want to look at even more is the verification and how I can improve that.
Any other questions for Kyle? We have one here in the front.
That was great, Kyle.
Thanks.
I've always been curious, and I haven't taken the time to figure it out. I'm wondering if you have, do you have any sense of whether the frequency or magnitude of any of these teleconnections has changed over time, or if there's like any kind of shift in phase over the long term?
You know, that's a good question. I haven't really looked at that. I don't think there's been any major changes over the years. I know ENSO, they've been updating things like the oceanic index that they use that accounts for changes in sea surface temperature over the years. So they use like a 30-year running mean, much like they do with temperatures and precip, and they adjust it. I think they've also done the same thing with the PDO. I'll have to check on that for sure. But as far as the other teleconnections, I don't know for sure. Yeah.
Great. Thank you. That's all the time that we have. Thanks, Kyle.
Right.
That was great.
All right, thank you.